Our interesting problem today is the fall of a ball through a curved way and collision with a box which moves in a pendulum. So we have a 0.2 kilograms ball here, which is released from Rex at a height of 0.4 meters above the bottom of a smooth curved track. The ball slides down without friction and moves horizontally. And then it hits a small box of the same mass, which is 0.2 kilograms, that hangs like a pendulum, which has a length of 0.3 meters. The collision is inelastic, and immediately after the collision, the box swings up and reaches a maximum angle of 30 degrees. Our goal is to find the maximum velocity of the pendulum here.
Firstly, we need to calculate the velocity at point 2. In order to do that, we know we have a height of 30 centimeters from here to here and a curve, the radius of 10 centimeters. So the height of total is going to be 40 centimeters or 0.4 meter. So due to conservation of energy, we know that because it's a frictionless track, we know the potential energy and kinetic energy of point 1 should be equal to potential energy and kinetic energy of point 2. So let's write that down. And because at point 1, we start the ball from the rest, but we know the velocity is 0, so the kinetic energy of point 1 is 0. And similarly at point 2, we know that the height is 0, so the potential energy of point 2 is 0. So we end up as So if we rearrange that equation, we can cancel out the masses, and then V2 squared should be equal to 2 times G1. And we can substitute that number, it should be 2 times 9.8 meter per second squared times 0.4 meter. Okay, and that gives us a velocity of point 2 at 2.8 meter per second. So we're going to point 3. Point 3 is right after the collision, where the ball hits the canister and they stick together. So in this situation, we have a law of conservation momentum. So which is m2 leading 2 equal to m3 v3. Our m2 is 0.2 kilogram. We got our v2 of 2.8 meter per second in the last part, and for the M3, which is M in the third part, the third point, we have 0.2 plus 0.2 plus it's canister and ball together. So the calculation is going to be 0.56 equal to 0.4 v3, and the velocity in the third part is going to be 1.4 meter per.
Alright, I'm going to explain you how to find maximum velocity for pendulum. Our canister will ball act as pendulum in this part. We consider this one our y0, and this one is the maximum height of pendulum, and it can go back and forth with an angle of 30 degrees. Our length of the pendulum is 0.3 meter, but we know when it backs to this point, which is point 3, it has maximum velocity. Its length is not 0.1 meter as well, because we have another height which is away from our y0 equal to 0. So I call that y4, and in the next part we are going to calculate this part as well. But first, let's try to calculate what is the maximum velocity of pendulum at point 3. All right, we have kinetic energy point 3 plus potential energy point 3 equal to kinetic energy point 4 plus potential energy at point 4. What's important to note that, alright, the pendulum at point 3 doesn't have actually any height. When it reaches here, it's 0. So its gravity, the potential energy at point 3 is 0, but it has kinetic energy because it has a speed. What is important to know as well is that at point 4, it has its velocity is 0, not maximum, and then go back and forth. But at this part, its velocity is 0. So what we have here is 1 over 2 n, which I call it Bm because it's ball and canister Bm, B3 squared equal to mg by 4. I want to take a little bit about y4. I think I already mentioned that the y4 is the pendulum height from the y0. And we will figure it out in the next part. We can cancel out the m's, and what we can derive from this part is b3 is equal to 2g by 4. I want to mention that this b3 is different from that one that we calculated because this one is our maximum pendulum velocity. Why? Because it'll start move and back and forth, and at this part it has its own maximum velocity, and it's pretty different with what we already calculated before collision or after collision. Well, I'm going to explain what is y4. It's a triangle. Based on the triangle, we can understand that r minus y4 is equal to r cosine theta. So when we know that r minus 4, y4 is r cosine theta, we can understand that, okay, equal our r minus r cosine theta is equal to our r minus y4. Okay, what is our y4? Isn't it? It's r minus r cosine 30 degree. The factor of our r and y4 is r 1 minus cosine 30 degree. Okay, let's put this one in our equation that we had from last part. If we want to find our Vmax at point 3, it could be 9.8 meters squared to this one. This r is 0.3 meters.